Okay, so this is lesson 2 video for water erosion. So we're going to cover out everything that water does kind of briefly. And the first thing I kind of want you to think about and do is consider the Grand Canyon. So the Grand Canyon is this enormously long, huge area that has been carved out by the Colorado River over millions of years. Okay? And all of the material that was here is now sediment somewhere. Okay, and if it weren't for the Colorado River going through here and doing all this erosion, this would just be a big flat area. You'd look, hey, look at the Arizona desert, isn't it flat and boring? But because this river has been doing erosion, it's created something really beautiful and huge. Okay, so water erosion is responsible for the Grand Canyon. If you take a look at the top of all of these little areas here, it would be a very flat area if it weren't for this. Now, water and stream erosion, like we said, that's responsible for the Grand Canyon. Many years of erosion have carved a huge canyon. And we're going to talk more about how slope and everything affects this. But the other type of erosion I want you to note is called wave erosion. It's what happened to this tree. So over time, when this tree was first, a young tree, the soil was way up here, and it was probably 100 or 200 yards from the beach. But over time, the water has just slowly pulled back on the sand, and it's eroded all of this away. So much so that the land, instead of being up here, is now way, way, way down. And this tree has had to grow very strong roots in this direction to make up for it. So here's wave erosion. Waves can remove large portions of beach, especially during storms. That's wave erosion. So in class, we should see a nice video about wave erosion, taking the beach and basically washing it out to sea over time. And moving on to the bottom of the page here, we have some terms I want you to know. The first one is deposition. Now on the stream table, you'll see that the sand is all piling up at the bottom. This is called deposition. And that's where the sand falls out of the water. And it happens as the water slows down. So later on here, well, down here we have the mouth of a river where the river meets a large body of water. This Mississippi River water is moving pretty quickly through here, and then it slows down. So deposition is going to be happening right there where the sand is being dropped because all this water is now going slower. It can't hold as much. So deposition and mouth kind of go together. Okay, so deposition where the sand falls out of the water, and mouth where a river meets a large body of water. Well, if this sand right here, where the mouth is piling up, it can make what's called a delta. Okay, a delta is where the sediment piles up to makes new land at the mouth of a river. So oftentimes you'll see a river end, and then you'll have this little patch of triangular land. It's usually really low, but it's also very good farmland. That's called a delta. Here's a picture of one. So you should see that these three words are put together. Deposition at the mouth of a river causes deltas. Last thing I want you to know, and we'll talk about this more later, is how a meander is a curve in a river. If you're meandering, you're just wandering this way and that. Rivers meander more and more over time. Now, the second page of the notes. How does slope affect erosion? As we see in class, if we take a stream table and increase the slope, we doubly increase the amount of erosion that goes on. So the increase in slope increases erosion by a lot. Now I've got a graph here. Okay. The bottom part of the graph has to do with the slope. So here is zero slope. This is a horizontal line, and then moving across here, this is sloping higher and higher and higher. Kind of like this line. So here's slope 0. Here's a slope at maybe 15. Here's a slope at probably 30. Right here, 30% slope. Okay, so I'll leave this here to indicate 30. here is a 15-degree slope. Okay. Now if you imagine, there's going to be a little bit of erosion here, but there's going to be much more erosion here. What this graph is showing you is that, well, a plow, which is what farmers used to use to plow up their fields, would cause a lot of erosion. At just 5 degrees of slope, farmers were losing tons and tons and tons of land, of their soil, due to erosion. And so that's why lots of farmers went to no-till. And so farmers weren't tilling up their land. They weren't plowing anymore. And so the root systems from the old plants were able to hold on to a lot of that soil and decrease it. Now, no-till isn't the best. What you could do is put a cover crop, like oats or something, it looks like grass. With grass growing on top of your fields, you'll have even less erosion. Okay. And then the rest of these, a forest stays down here almost at the very bottom for erosion. That those trees really hold the land together. So why did most farmers switch to no-till farming in the past few decades? Well, there's far less erosion. Far, far less erosion as compared to spring plowing, where there is no cover at all on the land. Okay, on to how rivers form. Now, rivers, we're going to see a lot of this in class and with the sandbox. Young rivers are very different than older rivers. So a young stream is going to be very straight on a steep slope. Excuse me. So a young river, like I said, is very straight, fast, has a steep valley around it. You'll see that they erode a lot. Okay, so these young rivers haven't had a lot of time to work yet, but over time they change into what we would call a mature stream. Okay, they have a more moderate slope. So a mature stream will have some meanders and it'll be a medium speed. I mean, there'll be cuts and there'll be hills and valleys. But over time, as that stream meanders and cuts more and more of the valley away, what you end up with is an old stream. These take a long time to form, but you know when you see them, they go all around in the area. Okay. And it's usually very flat land. You can see that there are places where the stream has been. And old streams are very slow, and they're curvy, and like it says here, they're gentle. So streams age, just like humans. When they're young, they look more like this, but as they get older and older, they change. So the last part of the notes talks about why streams meander. So what we end up with is a stream that might have a little curve in it like this. Okay. Now that stream curve actually has a lot going on in it. So on this outside of the curve, you're going to have water that's moving faster. So this faster water, so that's why the faster is written here, faster water is going to cause more erosion on this side, whereas there's slower moving water on this side, so the water's moving slower. There's actually deposition going on over here. So over time, this side of the stream will build up, and this faster water will cut away at the stream over here. So the stream will end up moving this way slowly over time, just because the faster water is moving more sediment on the outside, but it's dropping some sediment off on the inside. So over time, what we end up have is like a stream like this. And the same problem is happening. Okay. So the stream is moving this direction, but if you see there's another curve here. So this part might be moving this way. And maybe this part is moving up this way. So because there's deposition happening here, there's deposition happening here, and same down here, the curve can get more and more severe over time. After this moves a little bit more, the stream might look something like this. Okay? And that stream keeps it up. So there's more deposition going on here. There's more deposition happening here. More deposition happening here. We're making it move that way, and these sides coming in. Well, what might finally happen is that these curves get so severe and pronounced that eventually it gets so curvy that the water ends up breaking through here, and it makes a new channel right through there. And so now the water, the easiest pass for the water is going to be through here, and there would be some deposition happening right here. What you end up with, this little body of water, which is, there's still water in here, often is called an oxbow lake. You have a stream then, which might meander somewhere else, but an oxbow lake has formed where the body of water was, but it's since been cut off. So that's how we get oxbow lakes. If you need to look it up, if this doesn't make sense, there are tons of videos of how oxbow lakes are formed. So if you need to watch a different video, all you have to do is search, and you can see dozens of different videos showing you exactly what I tried to show you here. This is it for Lesson 1 notes. Let me know if you have any questions.